Hello and welcome to Skyworks Power Supply Design video series. My name is Tamás Pani, I am an application engineer at Skyworks, and in this video I will offer insight into RC snubber design. In the first part I have discussed the theory behind snubbers. Why are they needed, what they do, and the different implementations. Now in the second part I will continue with the RC snubber design process. How can you tell which parts to select in the design phase, although most of the parameters will be finalized after a tuning process, which I will also discuss in detail. From the final section, you can learn which part of the design has an impact on the snubber and how can you make sure that it will work as expected, even if you need to change the original design. If you are interested in the theory behind RC snubbers, check out the first part of snubber design for SI34-0X. Now let's take a look at the design process. For the capacitor value to be much larger than resonance circuit capacitance, we have to estimate the latter. We can use the datasheet of the semiconductor to take the output capacitance and use that to calculate a rough estimate for the snubber capacitor. This value will be calculated more precisely during the fine-tuning process. Voltage rating of the capacitor depends on where the snubber is located. Primary side snubbers are more common in non-isolated power supplies and must bear the input voltage with the added peaks during switching. For power over Ethernet, we recommend a 100 volts rating. Secondary side snubbers are exposed to the output voltage with the added peaks. As an estimation, you can double the output voltage and use that as the voltage rating. The resistor value must be close to the impedance of the parasitic resonance, which is hard to estimate but must be fairly low, usually below 10 ohms. It will also be calculated precisely during the fine-tuning. More important in the design phase is the estimated power dissipation of the resistor, which will determine the size of the package for the layout design. This can be calculated from the selected capacitor value and the voltage rating of the semiconductor. After the design is done and the first working prototype is built, then the fine-tuning can be performed. First step is to measure the resonance frequency at full load with no snubber parts placed. This can be done using an oscilloscope measuring the voltage on the semiconductor. In this example, the measured resonance frequency is around 47 MHz. For the next measurement, you have to implement a short in place of the snubber resistor and find a capacitor value with which the ringing frequency will be half of the resonance frequency. Start with the calculated value and change it little by little. The frequency is inversely proportional to the capacitance, so if the frequency is higher than half of the resonance, you need to add more capacitance. This will be our snubber capacitor. Based on the snubber capacitor value, you can calculate the parasitic values of the switching circuit. This is what we need to calculate the snubber resistor value. The equation of the parasitic capacitance is very simple. Keep in mind that this is only true if the ringing frequency with the snubber capacitor added is half the resonance frequency. Parasitic inductance can be calculated from the parasitic capacitance and resonance frequency. Now that we have both parasitic capacitance and inductance values, we can calculate the snubber resistor value for optimal damping. With all the snubber part values and ratings in hand, what's left is to place the parts and check the results. A properly tuned snubber will leave some peaking but almost no ringing during the transients. Now let's look at what you need to do if something changes in your design or you want to modify an existing design, like an evaluation board for example. Take the equations from the fine-tuning process to see the dependencies of the part values. As you can see, they all are related to the parasitic capacitance and inductance of the switching circuit. If these parasitics are changing, then the snubber part values need to be adjusted accordingly. Okay, but when do the parasitics change, you might ask? To find out, let's look at the sources. These are the semiconductor, the transformer, and the layout. So if any of these are changed, then you need to perform the fine-tuning process. Thank you for watching. I hope you learned something new about the RC snubber design. For further information, visit skyworksinc.com.